functional properties have been met, and there's the traceability. So traceability is the key. So the software architecture need to be traced back to the software requirements, and you need to be traced to the software, to the system architecture as well. So this is an example of the throttle control composition. So this is the software architecture of the throttle composition. So you have multiple subsystems, and these subsystems we call software components. Yeah. So in order to calculate, to get your actuation of the throttle position, you need to have this software component interact, yeah, to achieve that output. Okay, now, after we have finished the software architecture, then the next step is to do the software unit detail design and unit construction. In this phase, what we do is basically we use the software architecture to help us define the smallest manageable piece of software that need to be implemented. Okay, so if you see an example here, you have now this is an implemented model, but you have, let's say, driver software request, you have a cruise control mode, and you have a target speed of the throttle. Okay, so this one, and this one, these are the software components. So this one we call it is a unit. So which means you can have a test for each of these independently. Okay, so the idea is software architecture will contain multiple software components, and this, which we also call software unit detail design. So the software unit detail design is exactly the same word as software component, and these are the components. Okay, and together they form software architecture. Yeah, so here it could be, these are the 3 units, but it could be part of the bigger picture. Okay, so that's the idea, is to define the smallest manageable piece of software that need to be implemented that align with the software architecture. Because you have already the software architecture at this stage, then moving on, you have software unit detail design, which basically to make sure that you design the unit to meet the functional requirement. So now you can see we have the controller, and inside the controller we have this driver software request. So if you look underneath, that's what you see. Yeah. So it means based on these inputs, you get your driver request. Yeah. And these inputs and how the priority, because here you can see that these has got the highest priority, are all defined on the software requirement. So the software requirement should give you on how you should implement this. And the architecture should say which subsystem should implement that, or which piece of software should implement those requirements. Okay, and moving on, now the software unit detail design also should ensure that the requirements are traceable into the model. So we need to have traceability in the model. So these tools, like you can see here, you are able to link the requirement. So that's why if you look back on, if you remember in the first early time of the presentation, I mentioned about to have a requirement, so to have a tool which talk to other tools. So you can see that this requirement could be exported or imported into the Simulink from another tool, and you do the linkage. So what the idea here, what you're trying to say is that this software unit detail design implement the requirement related to the driver switch request handling. Yeah. So it means the requirement related to that, or the software requirement, that are implemented in that subsystem. And requirement related to cruise controls are implemented on this subsystem, and requirement related to how you calculate the target speed for and the throttle valve is implemented on that subsystem. So what we have done here really, we have traced the requirement into our software unit design in Simulink. So we have achieved that traceability of the requirement into the model. Moving on, software unit design should be designed to make sure that this unit design is testable. So the software component by itself should be standalone and it should be testable. Moving on, so the software unit design also need to be able to meet some compliance checks. So the compliance check, there are multiple of them. So you may have something called model advisory check and model advisory check, and you may have something called polystatic analytics check. So this is mainly dedicated for the code analysis. So, but the thing is, like, if you see an example of model advisory check, we have some standard. For example, this modeling standard of MAHAB, so this is MATLAB Advisory Board, come up with a list of checks, okay? And those list of checks will make sure that the design which you have done meet the standards. For example, how do you name your components? There should be some specific standards. How do you do the configuration of the parameter? How do you do the signals, conditions, and all of that? And when you run the model advisory check, once you have designed your unit design in these tools, it will give you the status. You say, okay, go warnings, how many of those have passed? And if they have failed, if you click on this, it will say, okay, where they have failed and how you need to address them. Okay, so that's this model advisory check. Yeah, moving on, you need to generate code from implemented unit design. So the idea is we're trying to say here, you didn't code directly from the C. Maybe you code using MATLAB Simulink. Now you need to generate code. So once you have done the implementation, you do the model advisory check and so on, then you can do code generation. So you can generate code, and this code is the one which basically you're gonna take it to deploy to your dedicated ECU. And moving on, now we have covered the software requirements, software architecture design, and software detailed design and unit construction. So this one here, we say is explain how the requirements need to be implemented, which means is talking about how the software requirement, where about the system requirement usually talk about what, and the software architecture design contain all the software components or software units, multiple units, which need to be in that given software. That's why it's called software architecture. And the software unit design is one specific piece of code or piece of software within the software architecture. And then in each of these software architecture, you need to make sure that there are certain metrics have been met. So you need to make sure that you have performed the compliance analysis check. And also you need to make sure that whatever you have implemented in your software unit design is traceable. Yeah, the requirement traceability in the model should be done as well. So that's the part of the software engineering activity. And moving on, as I said, because of time, we won't cover the ones in yellow. So I'll move to the software unit verification. At this level here, what we have done is we have done the design and we have traced the requirement into the model. How do we know that this requirement met basically how do we verify that this software component meet the requirements of the software? So we have traced the requirement, but we need to verify those requirements. Yeah. So tracing the requirement into the model is just linking the requirement, but verification is to make sure that that piece of logic, if I run and test it based on some test cases, meet my software requirements. So that's what we're going to cover on the testing aspect. Yeah, in the testing aspect, which is a software unit verification, which is the part of software requirement session on the V cycle, which is SW4, SWE4. In this case here, what we're doing is we are focusing on verifying individual software components that they meet the requirement. That's the key aspect. So it's all about testing. So you see, for the same software component, which I showed you, which is the software components, multiple of them, with these requirements linked into that. So the first tab here, which we done during the software unit design, we check if the requirements are linked, which is talking about linkage of the requirement and implemented. So these requirements have implemented. And there is another one which is talking about requirement have been verified. Okay, so the verification of the requirement. So that's the part of the requirement. And to verify these requirements, it means we need to come up with some test cases. Okay. And then we need to ensure we have done model in the loop testing or mill testing and software in the loop testing. So model in the loop testing, which means for the given driver software request, we can create some different test cases. And these test cases, basically, they should be driven from the requirement. So for example, we may say enable button. Yeah. And in enable button, we look at the requirement expectation, the software requirement expectation. We write a test case for that, and then we simulate the system, and then we can compare that what is a request and what is a response. Yeah. Ideally, if I put on top of this, this should match, and then you're gonna get green. But if that test case didn't match, then you get the failure, which will be a cross. So you'll have multiple test cases, and the coverage of these test cases should be 100%, which we call it model coverage and condition and decision coverage, MCDC. You should have get 100%. If you are not getting 100%, you should have a reason why you are not achieving that. It should be justifiable. Okay, so that's this for model in the loop testing. And then for the software in the loop testing, you can change your simulation mode to the software in the loop testing. So the thing is, the software in the loop testing use exactly the same test cases. You are not changing the test cases, except in this case, you are testing the code in the loop, not the model in the loop. So in this case, you need to generate the code, and that's the code you are testing to ensure that whatever you have done in Simulink or in your on your model-based design is exactly the same what the code is doing. Because sometimes what you may have when you generate code, depending on the configuration, the code could be different from what your system is doing. So you need to be careful with that. So that's why we need to do the mill and seal testing. And then of course, yeah.
May I interrupt you? We have like 3 minutes.
Oh, okay. Okay, so I'll rush a bit. Okay, so that's part here. So moving on, just gonna touch on quickly because of the time. We've got 3 minutes. On the certification and compliances. Yeah. So everything we do to be able to produce a product which will go to our customer may need to go through a phase of certification and compliance. So I'll touch 3 things around here. Probably will spend 1 minute on each. The first one is emission certificates. Yeah. So if you are selling a car, internal combustion car, or plug-in hybrids or hybrid electric vehicles, you need to be compliant with some emission standards. And also there's another standard which is related to the cyber security and software update. Also, you need to be satisfied on that. You also need to be satisfied in compliance to the UNEC 10. So UNEC 10 is talking about electromagnetic compatibility. So moving on, OEMs, which is automakers like ourselves, we need to be compliant to, for example, emission standards, as I mentioned. So in Europe, we have European Union standard. So there's a Euro 1 to Euro 7. So Euro 1 was introduced in 92. And the latest one, which is coming this July, expected to come this July, we'll be talking about is going to be called Euro 7. And Euro 7 basically will be focusing on reducing the NOx. So, NOx is more harmful. I think you may know that, especially back home, you have those bajajis, um, you have border borders and all of that. Basically, because the emissions level are not regulated, so you may have a large amount of NOx, nitrogen oxide, and this is quite harmful. And most of the respiratory disease and cancer cases, they come from the NOx. And then you have things related to the particulate matters and CO2, hydrocarbons, and all of that. So Euro standard is aimed to focus on that. And they are quite, this Euro 7 will be quite tight in terms of regulations. In the United States, they have their own as well standards. So they have EPA, which is Environmental Protection Agency. In California, they have much more stricter rules. So they have something called CALB, which is the California Air Resource Board. China, they have China 6. So China 6 is pretty similar to Euro 6, which is used in Europe, and is more stricter to the NOx and PM. And then you have other countries like Japan, India, Canada, even South Africa. So basically, they adopted, they have created their own standard, but adopting from US and EU standards. Yeah. So that's it for emission. And moving on for the and now there's a lot of cyber security concerns. So the UNEC, United Nations Economic Commission for Europe, UNEC, came up with some regulations, basically become mandatory in 2022 for the new vehicles. And this basically in order to protect against the cyber threats and make sure that the vehicle is safe through the life cycle of the vehicle. Once the vehicle is manufactured, we need to make sure that we have mechanism to update that. So here we are talking about, let me moving on. So we are talking about, this is a key aspect, it's the software over there updates. So the vehicle must be receiving security patches to address new vulnerabilities that may occur. So the idea is the UNEC 10 is imposing that when we're releasing a vehicle, it should be cyber compliant. And to be cyber compliant, there are certain metrics or certain requirements which we need to meet. So cyber security assessment, security and design, and also we should show that we have a mechanism to update the software over the air in case there is a new threat coming into the picture, because we know that the hackers always come up with a new malware. So which means by the time we release the software, maybe that malware is not known. If we come to understand that malware came into the picture, so we need to have mechanism in place that we can update through the air, over the air. And also the UNEC R156 actually is focusing on processes, on make sure that you have a robust process for the software update, traceability, validation, and verification before you deploy the software. So the idea is just to distinguish between R55 and 56. This is, you need to be compliant to the cyber. This one, R56, is the process for the software updates, which basically impose that one. So you need to have mechanism and robust process. Okay. And lastly, the UNC 10. So UNC 10, this is good
1
example.
minute, Dr. Hoffman.
Okay, yeah, 1 minute. Yeah, good. Yeah, so this is quite crucial, especially from it's kind of linked to the course which the students are doing for the 211. This is talking about electromagnetic compatibility. So in electromagnetic compatibility, basically, we're talking about the vehicle and passengers. So actually, it's for all vehicles, passenger vehicle, trucks, buses, and other motor vehicles. And the idea is concerning the electronic systems and components, and also for hybrid and electric vehicle, because we know that hybrid and electric vehicle, they got high voltage system in it. So we need to make sure that there is a humidity on that, especially the interaction. So the objective of USC 10 is to prevent against electromagnetic interference, to make sure that if you have uh, multiple vehicle in the on the roads, and they're emitting unregulated EMI, they could interfere between each other and could be dangerous. So we need to protect vehicle electronics, especially for the function safety, and also we need to ensure that things like brake or steering are protected against the EMI. And also these UNC 10 basically create a standard which basically is harmonized and can be used by different UNC members. So the idea is like you don't want everyone to come with their own standard. So it's a standard which everyone need to follow, and everyone make sure that that we are compliant with. I've rushed through, but yeah, thank you for listening, and I hope you have got something out of this. Um, but if you have any question, please feel free to contact me on the email attached there. So it's ogm100@yahoo.com. Thank you very much. And thank you, Dr. Jacqueline, for giving this opportunity to speak to your students.
Thank you very much, Dr. Hoffman. Really was insightful, and I hope the students have got an idea, really, when you see something, the end product, what are the process behind it, from the conception to the design to the manufacturing up to the testing and certification. So if there is anyone with a question, please, I welcome to ask. So it seems there is no any question. So
Yeah, I would expect at least one question. Yes, are they shy?
I don't know.
Yeah, usually like, yeah, you need to ask questions like it could be anything like which probably I may not have necessarily touched it, but maybe you wonder like, okay, how exactly these people are doing things, and yeah, around, the product development. Anything which, yeah, may come in your head, please feel free to ask. I need at least one question. Any one brave person could ask this.
Was it really understandable, or some of you are sleeping? It's a whole process, but I think you have seen some of the components that we are learning in class. We are going to learn now some sensors. We have seen some converters, inverters. So each small component play a big picture of the engineering design. So it seems there's none, Dr. Hoffman.
Okay, yeah, no problem. Yeah.
Thank you very much again for your time. I know it's you have to wake up very early, but really it was insightful, and I hope they have got the idea really of what engineering design has to be done and what are the procedures. So as you have seen, now everything with the AI, everything is integrated with software. So you might not be a developer or a software expert, but at least you have to know the hardware part and how to integrate it with an expert with software. So software is not out of the question for the ongoing use and design of electronic equipment.
Yes, they are very, very much interlinked. Yeah.
Asante sana, Dr. Hoffman. Then
Asante sana.
I hope next time we'll have also the same and time to share your knowledge.
Yes, yes, and I hope for the next time probably will be if I can, if I'll be in Tanzania, will be good, so we can have interactive discussion, face-to-face discussion, because I know that, yeah, maybe some of you, yeah, we haven't met before, so it will be good to have maybe another session when I come to Tanzania and we can do face-to-face as well.
Okay, that will be good. Asante.
Asante, thank you. Haya, kwaherini.
Okay, bye.
Okay, bye.